Hello, Dr. Ogden. Today we're going to be looking at some of the essentials in chemistry for biology. So you might be familiar with the periodic table of elements, where each of these boxes represents one element that has an element symbol, an atomic number, and a mass number. And of all of those elements, about 25 are essential for life. Of the 25, there are 4 really important ones: oxygen, carbon, hydrogen, and nitrogen. There are some others that are not quite as plentiful in life, and then there's even this group of elements that are called trace elements that are also important. Now, of these trace elements, they are also really important, but you need them in small quantities. If you do not get the necessary amounts, you can develop problems. For example, here, an iodine deficiency can cause goiter, and so we have salt that's been iodized. Now, whenever two elements or two or more elements come together in a fixed ratio, we call that a compound. So here is an example of a compound. Sodium and chlorine came together to form sodium chloride, or salt, table salt. Now, an element consists of one kind of atom. And so when we look at an atom, we know that it has a nucleus and that it has this cloud of negative charge around it. The nucleus then can have different numbers of protons and neutrons, and also you can have different numbers of electrons in the electron cloud. And those different numbers is what determines what kind of element it is. So for example, if you have an element that has 6 protons, it is carbon. That is the atomic number. Its mass number is made up of both the protons and neutrons. So carbon-12 has 6 protons and 6 neutrons. And it also has 6 electrons here. And that way it is an uncharged atom because it has the same number of protons and electrons. Protons have a positive 1 charge and electrons have a negative 1 charge. But you can have carbon that is in different isotopes, where the number of neutrons can differ. So now we have 6 and 7, and so the mass number is 13, and we call that carbon-13. Or 6 and 8, where the mass number is 14, and we call that carbon-14. So that's the inside in the nucleus, but these electrons around the outside are arranged in a very specific way. They're arranged in what we call electron shells, or valences. And the first electron shell can hold 2 electrons. The next electron shell can hold a maximum of 8 electrons. The next electron shell can hold a maximum of 8. And there's a pattern that goes up, and you can look that up. But the important thing is that atoms typically want to try to fill this outer electron shell in a number of different strategies. And this property of atoms trying to fill their outer electron shells is what causes atoms, when they come in proximity, to bind with one another and to form compounds and to have chemical reactions. One of the important types of bonds that occurs is what's called an ionic bond. And here is where one atom, like here sodium, gives off an electron to the neighboring chlorine atom. So now you have a sodium atom that has one more proton than it does electrons, so it has a positive charge. And now the chlorine atom is now a chloride ion, and it has one more electron than it does protons. And now the positive and negative atoms attract one another, and you form the compound sodium chloride. So this is ionic bonds, where you have a give and take, and then you have opposites attracting. Covalent bonds are different. This is where atoms look at each other and basically say, hey, I need to fill my outer shell, you need to fill your outer shell, let's share. And so there is a sharing of protons that is done. Like here, hydrogen is sharing 1 electron with a neighboring hydrogen atom, and therefore you have hydrogen gas. Now, chemical reactions is where you break existing bonds and you form new ones. And you can always do this by writing it kind of like an algebraic equation, with the reactants on one side, the products on the other, and the arrow indicating the direction of the reaction. Here, 2 hydrogen molecules combine with 1 oxygen gas molecule to form 2 molecules of water. Notice you have the same amount of atoms on each side, just arranged differently by having different chemical bonds. So this really brings us to what we're interested with biology, the molecule of water. Water is really what brings life to this planet, and that's why when we try to look for life on other planets, like on Mars or even further beyond that, what you look for first is there evidence of water? Because if there's water, then there can be life. So what's so interesting about this little molecule that has one oxygen and two hydrogens? Well, it turns out that the sharing, the covalent bond that's taking place between the hydrogen and the oxygen, allows that the electrons that are being shared are unequally shared between the oxygen and the hydrogen. So essentially the electrons, which are zooming around these things, right, at nearly the speed of light, spend just a little bit more time around the oxygen than they do around the hydrogens. And so you get this unequal sharing, and thus water becomes a polar molecule with a side that is overall positively charged and a side that is overall negatively charged. Then when you get a bunch of water molecules together, they start to bind to each other, and that's called the hydrogen bond, where the positive end of a water molecule binds with the negative part of another water molecule. It's these hydrogen bonds that allow water to bring life. How? Well, this allows for these four different things to happen: cohesive nature, the ability to moderate temperature, the ability of ice to float, and then the versatility as water of a solvent. And we'll look at each of these quickly. Cohesion of water. This is that water molecules stick to each other. So they have this stickiness property, this cohesive property. This is how you can get trees to bring water in their roots and get them all the way up to the very top of a tree. Or this is how insects can walk on water, essentially, because they don't break the surface tension because the water molecules are sticking to each other. Water can moderate temperatures. So for example, if you look at the temperatures in San Diego, you see that there's a range of about 50 degrees in the coldest time in the winter to up to about 78 degrees in the warmest time in the summer. And that's it. Where I live here in Utah, we get way below zero and even above 100 because we don't have large bodies of water that moderate the temperature. This also can be looked at in the way of evaporative cooling, which is a really important way that many organisms keep their body temperatures at a fairly constant temperature in order to not overheat, right? So a very large organism like Shaquille O'Neal needs to sweat a lot in order to have that evaporative cooling. Ice floats, right? You know this, it floats in your cup. And the reason it floats is because the hydrogen bonds, when they are put together in ice, are spaced, the atoms become more spaced out because they kind of get crystallized into this very stable form. The liquid form of water allows the molecules to be closer together and to bump into each other. And so the ice form is less dense than the liquid form, and therefore it floats. This is important because if ice did not float, everything in the ocean and rivers and lakes would die during the winter because you would have ice, the water would freeze from the bottom up. And the last important part of water is that it's a solvent. Now, the dissolving agent is called the solvent, so that's usually water, and the dissolved substance is called the solute. So in this case, I have a glass of water, you put some salt into it, and you stir, and pretty soon the salt crystals dissolve. What that means is the water molecules surround each of the atoms of these ions. So it surrounds the sodium ion and the chloride ion, and basically it keeps doing that, and then that's why the crystals disappear. Now, if you keep adding salt, you're eventually going to get to a point where you have no more water molecules to surround these ions, and so they stay in the water, and you can still see them. So water as a solvent then can bring on different properties where, for example, if you have lots of OH negative groups, you can form a basic solution. So things like seawater, milk of magnesia, oven cleaner. Or you can have water that's fairly neutral where the positive and negative ions are about the same. If you have lots of positive ions, then you can have an acidic solution like tomato juice or grapefruit juice. And this is important because life needs these different pHs in order to perform different functions. If you want to eat something, you need to be able to increase the pH down in your stomach so that you can dissolve some of the substances. So this is a really important part of life as well that water provides for us. And that's really what we wanted to get at today. We learned all about chemistry to basically learn about water and how water provides these life-sustaining properties.